Hi, I am Dr. Kuldeep. Today in this session we are going to discuss about the ultrasonic sensor, and then we will find out the distance of one object with the help of this ultrasonic sensor with Arduino. It is an HCSR04 ultrasonic sensor. It uses sonar to determine distance to an object like bats do. It offers excellent non-contact range detection with high speed accuracy and stable reading in an easy to use package. It has generally range from 2 cm to 400 centimeters. It has 4 pins: VCC pin, trigger pin, echo pin and ground pin. First, VCC pin, and this VCC pin powers the sensor typically with 5 voltage. So we connect this pin with the 5 voltage supply pin on the Arduino boards. And second is the trigger pin. This trigger pin is an input pin, and it has to be kept high for 10 microseconds to initialize measurement by sending ultrasonic waves. And this pin is connected with a selected digital pin number that will be selected during the program executions, and then we connect this with the Arduino boards that will be selected. And third is the echo pin, and this pin is an output pin, and this pin goes high for a period of time which will be equal to the time taken for the ultrasonic wave to return back to the sensor. This pin is also connected with the digital pin number on the Arduino board that will be selected during the program design. And the last pin is the ground pin, and this pin is connected to the ground of the systems. Now there are two sensors on this board. One is T, second is R. T for transmission, R for receiver. And as we discussed before, there are two pins, trigger and echo. And when a signal of 5 voltage is sent over the trigger pin, this one, for around 10 microseconds in order to trigger the sensors. When ultrasonic sensor gets a trigger signal on its trigger pin, then it emits an ultrasonic signals from the transmitter like this. And when ultrasonic sensor reflected back after hitting some object in front of the sensors, this reflected ultrasonic signal is then captured by the receiver of the ultrasonic sensors. As the sensor gets this reflected signal, it automatically makes the echo pin high, and the time for which the echo pin will remain high depends on the reflected signals. Now we read this time for which the echo pin is high and calculate the distance. Its distance L is equal to 1 by 2 T into C, and T is the total time from transmitter to receivers, and we divide by 2 to calculate the distance from sensor to object, and multiply by C. C is the ultrasonic speed, that is 340 meter per second. Now we will discuss about a sketch of ultrasonic sensor. First we define the two main pins of our ultrasonic sensor, trigger pin and echo pin. We define trigger pin as 2 and echo pin as 3. We define trigger pin as 2. This means we will connect our trigger pin of ultrasonic sensor with the digital pin number 2 on the Arduino boards. And echo pin is 3. In this we will connect our echo pin of ultrasonic sensor with the digital pin number 3 on our Arduino boards. Set of functions. It is the main functions of our sketch. In this we initially use serial.begin 9600. This means we initialize our serial communication and sets data rate to 9600 bits per second. Now we initialize the sensor pins, trigger pin and echo pin. Trigger pin as the output, it will emit the ultrasonic waves, and echo pin as input, it will receive the reflected waves. Now loop. In the loop we initially digital write trigger pin as low, and then there is a delay of 2 seconds. This will low plus 4 handed to ensure the clean high pulse, and then we'll trigger high and trigger pin low. Now we will take reading of the echo pin, that is high, and store this value into the durations and pass this duration, that is in microseconds, into the centimeters with the help of the microseconds to centimeter functions, and store this value of centimeter into the cm variables, and we will print the cm variable. Then we will use a delay of 2000 milliseconds so that the next output can be printed after a short time of delay. It is the microseconds to centimeter function. In this function we pass microsecond durations as a microseconds, and we will divide this by 29 because it is the ultrasonic waves speeds, that is 29 microseconds per centimeter, and then we will divide by 2 because the ping travels out and back. So to find the distance of the object, we will take half of the distance traveled and return this value by these functions and store it into a CM, and we print the output. It is the sketch of the ultrasonic sensor for the Arduino board. Now we will discuss about the ultrasonic Arduino board setup. The first jumper wire that is connected with the ground pin of our ultrasonic sensor, and we will connect with the ground of our Arduino board. And the second pin is echo pin. We will connect this echo pin with the digital pin number 3, that is previously we have designed in our sketch, that it will be connected with the pin number 3, digital pin 3. And the third pin, that is trigger pin, we will connect our trigger pin with the digital pin number 2 as designed in the sketch. And the fourth pin is VCC pin. We will connect this VCC pin with the 5 voltage power supply of our Arduino board. This one. And now we will run the program, and we can calculate the distance of one object, its distance from the ultrasonic sensor. As we move it close to the sensor, it will reduce the distance, as we can see in our output like this. Click on this serial monitor and we can find out the distance of object. It's 12 centimeter, and we will move close the object. It's 10 centimeters, and we further move it. Now its distance is 8, and now we move close to the sensor. It's 6, it's 5, and now we move in the backward directions far from the sensor. Then it's 6, it's 9, it's 12, and thus we can find out the distance of one object with the help of the ultrasonic sensor with Arduino board. Thank you for watching my video, and please subscribe my channel.